In this video, I'm going to go over how to get the answers to the week 2 quiz. So we're going to start with problem number 1. It says using the data, determine which one of the answers is correct. So in order to answer this one, I'm going to get my TI-83 calculator and I'm going to get the data because it looks like we are comparing the mean and the median. So I'm going to put this data into our table here. So stat and then edit L1, 4, 14, 24, 34, 44, 54. And we'll go over to L2. And the frequency 25, 15, 10, 9, 4, 1. Now that I have that in here, then I can go back to stat and calculate. I want to do the one variable stat, just hit enter, and then I want to do L1, comma, it's important that you have that comma, L2. I want to pull from both of those. So here are my statistics. Remember that the X bar, this first one, the X with the bar over it, is our mean. And then we can scroll down. So the mean is 16.96. We'll scroll down and we can find the median is 14. So if we look at this, the mean and the median are equal. No. The mean is smaller than the median. No, the mean is larger than the median. Yes, so your answer should be this last one. Problem number 2 is interpret the box plot. So to do this one, remember that a box plot, each section is 25% of the data. No matter how big or small the whisker is or the box is, it each represents 25% of the data. So this is 25, so we'll zoom in. Then that means this is also 25, this is 25, and this is 25% of the data. So if we look at the options here, 75% of the data are at most 5. So 5 would be the highest. And if you look here, you can see we've got 25 plus 25 is 50 plus 25 is 70. So 75% of the data is at most 5. That's correct. Let's just go over these other ones. There is about the same amount of data from 2 to 5 as there is 5 to 7. Well, 2 to 5, there's 50% of the data. 5 to 7 is 25, so that's no. There is no data values of 3. That's not true. There could be 3 in here, and 50% of the data are 4. No, that is also not true either. So the answer is the first one. Now let's take a look at number 3. It says, in a set of data, if all the data appear with the same frequency, then we have to pick which one is true. It says, hint, put an example in your calculator. So if we go back to the stat button, and let's just go ahead and clear out our lists, L1, comma, L2. So now we can go back and we want to edit. So it says a set of data, the same frequency. So we'll just make up some data, 1, 2, 3, 4, 5. And then they have the same frequency. So let's say 1 is 5 times, 2 is 5 times, 3 is 5, there's 5 3s, 5 4s, and 5 5s is basically what we're saying. So they're talking about standard deviation, the mean, the standard deviation. Box plot does not always look symmetrical. So let's go ahead and find some of these answers. So let's do stat, calculate one variable stats. This can give us, on L1, L2, this can give us the standard deviation and the mean. So the mean in our case is 3. We'll do the sample standard deviation is 1.44. So it's not 0, so we can cross off this top one. All of the data have the same value. Well, we already know that's not true. The mean is always larger than the standard deviation. Well, in this case, 3 is greater than the standard deviation of 1.44. And then it says the box plot. So why don't we go ahead and take a look at what the box plot might look like. So second stat plot, enter, we want to turn it on. Let's go over and to the box plot. We want to do the frequency is list 2, and then let's graph it. And it looks very symmetrical to me. We could zoom if we wanted to, but it says the box plot does not always look symmetrical. Well, if the data all has the same frequency, then it should be symmetrical. So our answer is the mean is always larger than the standard deviation. For problem 4, it says find the 60th percentile, and there's a couple different ways that we can do this. So I'm going to walk you through the first way. So the first way is we are going to use the equation in the book from section 2.3, and it is I equals K over 100, and then times the quantity N plus 1. Okay, where K is the percentile we're looking for, and N is the number of data pieces. So we are looking for the 60th percentile over 100, and we multiply that by the number of pieces of data. So we have to go and add the frequency up. So I did that previously. 25 plus 15 plus 10 plus 9 plus 4 plus 1 is 64 plus 1. So then in my calculator, I just put this in. 60 divided by 100 is 0.6 times 65. And when you do that, you should get a whole number. It was 39. So that means that the 39th piece of data is the 60th percentile. So then I go back here and I look at my frequency. 25. So data points 1 to 25 are 4. And then, let's see, 25 plus 15 is 40. And so between 25 and 40, the data is 14. So 39 is 1 less than that. So the 60th percentile is 14 minutes. The other way you can do it, and I'm not going to show you how, but I did kind of a similar example of explaining the relative frequency, but you can calculate over here the relative frequency. So 39% of the data is 4 minutes. Then you could calculate the relative frequency for this by adding up the ones you know and subtracting from 1, and that would give you what this missing one is. And you would find out that the 60th percentile would be in here, which would give you the answer of 14 again. Next, we have question 5, which gives us some data, and it says, what value is 2 standard deviations above the mean? So this equation is also in your textbook. It is in section, just looking here. It is in section 2.7, measures of the spread of data. And if you look here, the equation is the value equals the mean, so you have to find that, plus the number of standard deviations. We want 2 standard deviations, so it's going to be a positive 2. If it said 2 standard deviations below the mean, it would be a negative 2. So just remember that. Times the standard deviation. So we have to find the mean and the standard deviation of this data, and we do that by using our calculators. So we are going to put the data in. First, we're going to clear these lists out. You'll get really good at clearing these. And our data is, we'll put it in list 1, 4, 6, 6, 12, 18, 18, 18, 200. We're going to go back to stat, over to calc. We want the one variable statistics. Hit enter, and then we want them for list 1. Enter. So we can see here that the mean is 35.25. The sample standard deviation is 66.83. So I plugged it in over here. The mean plus 2 times 66.83 gives us approximately 169. So that's our answer. For the answer to number 6, it says the following data, which of the measures of central tendency would be the least useful, mean, mode, or median? And in this case, it's mode. Mode is the most frequent number in a set of data, but when we think about statistics, if you compare it to the mean and the median, it is truly the least used of these 3, so we say that it's the least useful. Now let's take a look at problem number 7. Use the table below. What percent of the data is either 33 or 44 minutes? So what percent of the data? You should be thinking relative frequency is a percentage, so that we can look at the percentage of 34. It's 0.1406 plus, let's add the 44, which is 0.0625. Add those together, we get 0.2031. Change the decimal into a percent, 20.31%, approximately 20%. Number 8 is similar to number 7. 64 faculty members were asked the number of cars they owned, including spouse and children's cars. The results are given in the histogram. The percent of responses that were either 1 or 3 is approximately what? So if we look at this histogram here, if we look at one car, this 0.15 means 15%. And so 15%, I'm just going to convert it to a percent right away. And then 3, so 3 is at 0.25, which is 25%. So 15 plus 25 is 40%. So approximately 40% of the faculty members have either 1 or 3 cars. Number 9 has us looking at the same scenario as above. It says, which answer does not describe the data? So we'll start with the first one. There are approximately 10 faculty members that own 1 car. So we could do this by doing 64 times 0.15, right? About 15% of the 64 faculty members own 1 car, and that's 9.6, which we'd round to approximately 10 faculty members. That's correct. Skewed left. Well, if we look at the data, the majority of the data is skewed left, so it's not 1. There are no values of 5. That's actually very true. And skewed right. So it is definitely not skewed right, so that does not describe the data, and that's our answer here. And finally, let's look at the last problem. So we are again looking at the 64 faculty members and the number of cars they have. It wants to know what the third quartile is, and it says hint, put in your calculator. So I'm going to show you what we're going to do. I already cleared up my lists, so I'm going to go to Stat and Edit, and I am going to put this in this way. So number of cars would be L1, 0, 1, 2, 3, 4, 5, 6, 7 cars. So those are our options. We'll go over to list 2. There's none with 0 cars. There's 0.15 with 1, 0.45 with 2, 0.25 with 3, none with 4, none with 5, none with 6, and 0.15 with 7. From here, we're going to take a look at our one variable stats because they tell us our quartiles. So just hit stat, over to calculate, hit, put this up here, hit enter. Then we're going to put L1, comma L2. What we want to know is Q3. So right here it tells us Q3 is 3, so that is our answer. Email me with any questions you have on this. I'm happy to help you out.